Assalamualaikum. My name is Muhammad Syamil Azri from my family. I am representing for my group, which is Group 1. So today, me and my group members will present about our project titled Proposed Design of Elevator System for Buildings. Okay, lifts are designed to make our mobility easier, and this is the legitimate benefit of technology. There are a variety of different types and several lifts are being created and established to meet a variety of purposes. One of the most popular types of lift is passenger lift. It is exactly what it sounds like, a mechanism that transports people vertically in a complete restricted lift car. Passenger lifts are typically offered in a variety of sizes based on carriage mass. The lift can transport between 10 and 25 persons. This type is used in flats and apartments, lift in retail complexes, and other high-rise construction. Lift design necessitates meticulous attention to detail. The appropriate elevator design is determined by the size and the kind of building. A proper elevator plan contributes to a building's efficiency and safety. Elevators that are well designed can add to the overall aesthetic and feel of a room. As a result, travelers get a more seamless experience when traveling about the building and using the elevators. Therefore, this building is focusing on proposed elevator design for the BCB Berhad Company office building. Okay, so this project aim will be realized through achieving the following objectives. Firstly, to analyze the various types of vertical and horizontal transportation in building. Secondly, to prepare an effective solution in solving the assigned project. Thirdly, to propose the suitable design of building transportation in building based on the necessary calculation.
Hi, Assalamualaikum. My name is Radul Marif bin Muhammad Syamil. So I will explain about the literature review. Firstly, we talk about the project information, which is the project was expected to cost as much as 5 million and developed by BCB Berhad for business purposes. It was located at the lot 375, Mukim Bandar Penggaram, Batu Pahat, Johor Darul Ta'zim. And the last one, the design of the lift were using the selected design guideline from our local authorities and also international guidelines. So this one is our plan view, and the lift was proposed as that in the plan here. So on the next one is the lift design guideline. We had two guidelines, which is local document and also international document, which is for the local garis panduan reka bentuk lift, which is JKR standard, and the last one is the international document, which is Eurocode. Firstly, the selection of the lift was according to the types and also how the function of the particular building, such as indicated here. So the next one is the lift layout. The lift layout, the position of the lift can be made in various arrangements depending on the suitability of the room and the operation of the building. The third, the lift motor room. The lift motor room is also known as machine room, which is a room or enclosed space that house the equipment, machine, and electrical control for the lift operation. The construction of the lift motor room should be sturdy, weather resistant, and have a good ventilation system. This room must be made to specification set out in the factory and machinery. Electric elevator for passenger and goods regulation 1970, regulation 9. Number 4 is the material selection and the finish. The material type and the finish is according to the building category based on the guidelines and the regulation for the planning building. The proposed standard finish for the lift system by category of the building is as follows. First, the operation panels, which is referred to the table B9. Second one is the internal finish, which is referred to the schedule B10. And the last one, the hall and the landing entrance, referred to table B11. This one is table of B9, finishing of operating panel. We are using this according to the specification. The next one is the table B10, internal finishing. And the last one is the table B11, finishing of hall and landing entrance. So the last one is additional requirement, which is access card or VVIP access card. This one is optional but can be added. The installation of the access card or VIP access card system is for the purpose of the lift usage control according to the user needs and design guideline for building operating elevator system, and also the CCTV. Installation of the CCTV may be considered for security and monitoring purpose for vandalism. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Baiklah, saya akan meneruskan penerangan berkaitan dengan design prosedur. Seperti yang dapat dilihat di dalam slide, terdapat 6 step ataupun langkah yang disertakan, iaitu yang pertama adalah pengenalpastian masalah, kedua untuk kami collect ataupun mengumpulkan informasi data, ketiga untuk brainstorm dan analisis idea yang kami ada, keempat untuk kami membuatkan satu solution yang terbaik, kelima adalah untuk kami mendapatkan feedback hasil daripada design yang telah dibincangkan. Seterusnya yang keenam adalah untuk improvise perkara-perkara yang terdapat kekurangan. Seterusnya untuk work process pula. Yang pertama adalah discover. Untuk projek kali ini kami telah memilih Toshiba Elevator and Building System Corporation untuk second edition. Ianya adalah bertepatan untuk kegunaan bangunan kami, iaitu mempunyai 4 tingkat dan juga 1 ground floor untuk kami provide high quality product dan servis yang terbaik kepada pengguna. Seterusnya untuk define problem ataupun pengenalpastian masalah, terdapat 3 poin penting di sini, iaitu safety functions, service functions dan juga operations. Seterusnya, kami juga telah mengumpulkan data-data dan juga maklumat berkaitan dengan guideline, safety, operation, hoisting structure size, maintenance dan juga servis serta lain-lain perkara penting. Ini adalah bertepatan untuk kami mengenal pasti desain yang terbaik dan juga ianya bertepatan dengan keperluan penggunaan bagi bangunan jenis pejabat. Seterusnya adalah brainstorm dan analisis. Analisis yang kami buat ini adalah berkaitan dengan numbers of person, capacity of the car, speed, cage or car size, door width, hoseway size, machine room dimension dan juga motor capacity. Ini juga adalah penting untuk kami memberi maklum berkaitan dengan ruang yang diperuntukkan dalam bangunan untuk aplikasi elevator. Seterusnya untuk build pula, kami telah memilih jenis Toshiba P8C06CO60 jenis white car dan details ataupun kenyataannya adalah seperti berikut. Seterusnya, sistem yang diaplikasikan adalah automatic landing during power failure, home landing dan juga 3 to 4 car group supervisory control system. Ini adalah bertepatan untuk menyelesaikan kenyataan masalah yang telah disertakan pada awal tadi. Seterusnya, ini adalah sedikit gambaran berkaitan dengan hoistway ataupun ruang untuk lift kami.
Untuk seterusnya adalah lift traffic design calculation. Okey, ini adalah bangunan yang kami pilih, iaitu standard office yang mempunyai 4 tingkat dan juga mempunyai 5 stop off lift. Okey, so ini adalah butiran-butiran yang ada dalam traffic design untuk bangunan ini. Okey, so untuk POP, yang ini total population, adalah 204 hasil daripada kiraan berdasarkan formula ini. Okey, berdasarkan table A1. Okey, standard office adalah 10. Okey, seterusnya from the table A2, PHC adalah 12% daripada population. Okey, so jumlahnya adalah 24 people at the same time. Dalam satu masa adalah 24 orang. Okay, so therefore for the handling capacity adalah 24 orang lah. So this means that the lift system must be able to handle traffic properly with the capacity 24 people in 5 minutes. Okay, so the next is analysis. So kita akan gunakan formula ini. So for the next, we need to find the quality of service. Okay, so berdasarkan table A.3, the interval adalah 30 second. Okay, for the office building, okay, average adalah 30. So within 5 minutes, the total number of trips that can be complete by one lift adalah 10 trips lah. Okay, okay, so next we need to find the value person, which is P. Okay, okay, the lift system need to complete 10 trips in 5 minutes. Okay, then 24 passengers need to be divided into 10 elevated travel trips. Okay, so therefore one elevator unit must carry a minimum of 3 passengers for each trip. Okay, by referring schedule A.5, okay, Life capacity can be determined as follow. So berdasarkan kiraan life capacity adalah 204 kg. Okay, so kita akan rujuk pada table 8.5. Kita akan gunakan yang terhampir iaitu 450 kg. Okay, so value of P adalah 6 orang. Okay, seterusnya we need to find the hash value. Okay, hash is the maximum travel probability of an elevator. Okay, so untuk kiraan hash ni menggunakan formula ini, so total yang kita dapat untuk nilai hash adalah 3.7 second. Seterusnya kita kena cari S value ataupun nilai S menggunakan rumus ini. So berdasarkan formula ini, hasil daripada kiraan ini kita dapat 3.763 untuk nilai S. Dan seterusnya kita kena kira adjacent floor transit time. So untuk adjacent floor transit time ataupun TV menggunakan formula ini, okay. Dan berdasarkan daripada formula ini, okay, refer to table 8.7. The rate speed selected is 1 meter per second. Okay, so the maximum travel adalah 30 lah. So therefore for the TV adalah 4 second. Seterusnya performance time, which is T. Menggunakan formula ini, the T value can be obtained by using this formula lah. Okay, for this value, we use the table A.9. The TF1 is 7.1 second. Okay, so we look this table 1. Okay, untuk dapatkan 4.5. Yang paling hampir dengan 4 meter adalah 4.5. So the value is 7.1 second. Okay. So TSD start delay time, this value can be obtained from the manufacturer or set. Okay, so this value adalah dah disetkan iaitu 0.5 second. Okay, seterusnya. Alright, so for this study, the type of building is standard office. Okay, so then TAD adalah sama dengan kosong. So menggunakan rumus ini untuk mencari nilai T adalah 13.1 second. Nilai T adalah 13.1 second. Okay, seterusnya adalah TP value. So the TP value is the average time of passenger leaves and enters the lift. It can be referred to table A.11. Okay. So for the elevator of capacity of 450 kg with a dock opening size of 1100 mm, the value of TP which is 1.2 second. Okay. Refer to the table. So the capacity of lift adalah 450 kg. So the rate yang kita akan gunakan adalah 320 hingga 800. So the nilai the TP value is 1.2 and the typical door width adalah 800. Alright, so therefore the value of RTT is 86.1 second. Alright, so the next is the UPPINT. Okay, peak interval for 30 second or less. The recommended number of lift is 3 unit. So ambil dari nilai RTT tadi, kita dapat 86.1 bahagi dengan 3 untuk lift. So UPPINT value adalah 28.7 second. So the next is UPPHC calculation, unpeak handling capacity, menggunakan formula ini. So the value is 151 people. So out of 204 people in 5 minutes. Alright, so the next is service quality, check via POP menggunakan rumus ini. So the value for U is 163.2 people. So lastly, so the POP value we got 93% of the building population for 3 unit of lift provide service to all level within 5 minutes. So therefore, by referring to schedule A.2, 93% of the POP is suitable for standard office building because it exceed the standard set. So ini adalah nilai yang terakhir lah untuk bagi lift yang akan digunakan untuk bangunan office building ini.
As conclusion, transport equipment in buildings is an important tool for people to use to facilitate their activities, especially in multi-story structures. It concerns people work in terms of comfort and safety, and transportation management in the building should be arranged as equally as feasible while adhering to human safety requirements. On the other hand, it must normally conform with the Lift Regulation 1997 during installation and production. Elevators that are going less than 0.15 meter per second and their safety components that service structures and buildings permanently must be safe for use to meet health and safety criteria. The lifting operation and lifting requirement regulations has set standard on elevators used by employees in workplace. It requires elevators to be adequately examined by a trained person at least every 6 months or in the situation of good only lift every 12 months. Lift makers and other duty holders may turn to HSEs throughout inspections and testing of lift as standard source and advice. That's all from us. Thank you.